This is a production of Cornell University.
I was asked by Neil to continue this general topic of horticulture in a changing climate that they've had for the semester, and asked me to talk about fruit crops, and especially apples and grapes that I've worked on for quite a long time. And so I would be happy to do that. I would like to acknowledge Art DiGaetano from the Climate Center, and also Dave Wolf and Jonathan Comstock, as we've worked a lot together over the last year or so on a project funded by NYSERDA, the Energy Research and Development project to look at climate effects on various aspects. It's a very broad-ranging project on climate effects on New York. So I've been focusing on the apples and grapes, and we'd like to give you a quick overview of what we think are some of the important factors that are occurring now as well as in the future. But a lot of the climate information is from Art, so I have to definitely acknowledge his contributions there. So really some of the key questions are, has our climate been changing recently already? I mean, are we just looking at potential climate change, or are we really talking about a continuation of climate change? What happened, some of the effects on apples and grapes in New York due to the climate change? And then what changes are expected for our climate over the next 15, 20, 30, 40, 70, 80 years or so? And what are likely to be some of those effects? Now obviously there's lots and lots of things you can talk about, but first let's just see, point out that the climate is already changing. There's really not too much doubt about that, especially in the last 40 or 50 years. The annual temperatures across New York have warmed by almost 2 degrees Fahrenheit, which is a major change on a climatic scale. The winter temperatures are warmed by nearly 5 degrees Fahrenheit. So the winters are tending to warm up more than the summers, which is generally good for most of us. We're willing to let the winters warm up more. And then the date of last spring frost has become quite a bit earlier. I'll show some data on that. And that there are about 2 more days per year over 90 degrees Fahrenheit. And of course that varies with your location in the state, but there's been an increase in numbers of very hot days as well. This is a plot from Art just showing the general trend over about 100 years of the top line of the black regression lines is the 100-year trend, which is about almost 3 degrees warming over the last 100 years. But he also made a regression from 1970 or 1980, I guess it would be. I'm sorry, 1970. This is out to 2000. Of course, we've had some of the hottest years since that graph stopped. So the regression since about 1970 has been quite a bit steeper, with about 4.5 degree warming over the last 30 years, which is not only a large amount of warming, but it's a large amount of warming over a very short time period. And as mentioned, the winters have been warming more than the summers. Now this is from a project that Art worked with us on for the grape industry, but basically took his high-resolution algorithms to estimate temperatures between weather stations to get more of a high-resolution map of temperatures. And we had him go backwards for about 30 years and generate these high-resolution estimates of daily temperatures backwards for about 30 years, so we could summarize them over a 30-year period, which is really what you need to look at climatic change rather than just 5 or 10 years. What we could see is even in that short period, these plots are the average number of days per year with temperatures below -10 Fahrenheit. Now that's a threshold value for grapes, especially for grapes So that's sort of a key temperature for the winter hardiness issue for grapes. And so on the top left, you can see the plot in which on the left side of the scale are the warmer temperatures, the reds and oranges. Yellows are warmer, and then the blues and purples and greens are colder. And so in the upper left, you can see during that 1980 to 1990 period, what the general distribution was. And you can see why the grapes, the wine grapes that are growing in the Finger Lakes, near the lakes, a little bit up Hudson Valley, and then obviously onto Long Island, because those are the warmer spots. But then we just shifted to the last 10 years of the data set that were generated at the time in the lower right, and you can see by just comparing them significant changes in the warming of the winters and the numbers of days with these killing temperatures. So, and actually, if you look at Pennsylvania, you can see the really dramatic change. So these have been very strong changes in just quite a short time period. Now, some of the implications of that, we looked at those. That was sort of an overview. This is just Geneva data. And in the plot, you can see we plotted the coldest temperature each winter since 1948 or so on up to this year. And what you can see is, obviously, you're interested in the trends at the bottom because those are the ones that really cause problems for the grape and wine industry. And so I put a bar on there showing about -10 to -15 or 16 Fahrenheit is this sort of danger zone where if you're at -10 or so, that's into the bud kill point. Above that, you'll lose some buds, but it's not a commercial real problem. You get below -10, then you can really start having some problem. But since we removed most of the buds from grapevines anyway, we can tolerate a significant amount of bud kill. But then when you start getting down to -15, 16, you're looking at vine kill. So that's sort of your danger zone. And you can see that before 1980 or so, about every 4 or 5 years or so, there was a significant kill. And that was rather discouraging to growers. But since about 1980 until we had a couple of cold years there in 04 and 05. But since during that 22-year period or so, or 23-year period, we didn't have any dramatic, we had a little bit of bud kill, but not a significant winter injury. And I think this really allowed our vinifera wine industry to develop dramatically. In 1980, I think we had around 20 or 22 wineries, and now we have, I think it's about 300 now in the state. And many of them, most of them really have been interested in growing premium wine grapes. So I think these winter warming trends that we've had have been really quite positive for the grape and wine industry in New York. So that's an example of one of the positives of climate change. When you're on the cold side, you will see some positives. So, and then of course that was the winter. We can look at the length of the growing season, a similar way of showing this, and it is increasing. It's not quite as dramatic and easy to see, but if you look for the oranges and the reds, clearly you're seeing more of those in the later years, and somewhat less of the blues and greens. So the season has been getting somewhat longer as well. Then the warmth of the growing season. Is it really, are the seasons getting warmer? And again, comparing the same way, yes, it appears that you're getting more of the oranges and reds coming into New York. You can see the warming going up the Hudson Valley, and the Finger Lakes are getting warmer again. So again, quite a bit of evidence that says our growing seasons are getting somewhat longer, they're getting somewhat warmer. The winters are getting quite a bit warmer. And these can have talk about as such. The CO2 in the atmosphere obviously is one of the drivers for climate change, in that it absorbs infrared heat being irradiated from the Earth, and that's why it's a greenhouse gas. But it also has direct effects on plants, and we'll talk about that in a little bit. But one of the things that's very striking is how rapidly the carbon dioxide is going up in the atmosphere. Now, when I came, if you follow this 320 parts per million line over right about just above the printing, it was when I arrived about an infrared gas analyzer as part of my startup money. So I started measuring the CO2 in the air. It was 320 parts per million. Now it's 380 parts per million. So there's been a 60 part per million change in atmospheric CO2 just since I've been measuring it. Now, the point is that the atmosphere is changing rapidly, not that I'm that old. Yeah, I mean, I think some might think I should be measured in geologic time, but it's just the rapidity of the change in the CO2 is just astounding. And so just a comparison, I just went back and I circled that change that occurred over like 35 years versus one of the changes during way back when, and they estimate that it maybe took 50,000 years to have a similar type of change. So the point is not only going up and it's higher than it's ever been, but it's going up fast, and it's just not something that we can ignore. But it does have some, there can be some positive effects of that as well. So in general, you know, we'll see it's going to be a good news, bad news type of story. Yes?
Now, do they know what drove the CO2 down in that earlier time?
They do. I don't. We'll have to ask Gigatano. There's volcanic activities and a lot of geological stuff going on. So no, I don't really know all the reasons for that. Sorry. Okay. Also, besides temperatures, the rainfall has been changing somewhat. It actually hasn't, it's been increasing slightly. Generally the increases, when you have a warming period in a cold area like this, the increases in precipitation tend to be in the spring and the fall. Because in March or in October, November, when in the past it might freeze and be quite dry conditions and some snow, if it's warmer and the lakes stay warmer, then you tend to get more rainfall in that period. The summers tend to not change quite as much, but overall there's a little bit of a trend in precipitation being similar or increasing somewhat, but the tendency has been in a couple different things. One is that it's tended to be more erratic rainfalls, so heavy rainfalls, a 2-inch type of rainfalls occurring, and so if you have the same amount of total rain, but you're getting it in fewer major heavy downpours, then you may be expecting to have more droughts in between if you're getting the same amount of rain. Also, if you have a heavy downpour, a lot of times you get a lot of runoff, so the rain may not be as effective as more frequent small amounts of rain. So that's one thing we need to be aware of for the future, is that it's expected to have that trend continue more and more. Also, snowfall has declined by, it says as much as 20 inches in some parts of the state. I know around here, talking to people that have lived here all their life, they've seen quite dramatic change, drop-offs in the amount of snowfall. But in some of the lake effect areas, they've tended to get increased rainfall because of the lake surface temperatures warming up and providing more heat, more humidity for lake effect snows. So there's a lot of things going on, although the totals are really not changing dramatically. Also, we've looked, it seems as though we've been getting more droughts, and this is a long-term plot, more of a meteorological estimate of drought. And in this case, anything above the line is a drought. Anything below the line is more of a wet year. And so there was a period in the 1930s, that one highest peak I think was 33, and that was an extreme drought, and the Dust Bowl, that sort of thing. Those tended to correlate with the warmer temperatures at that time, that I believe is related to a high solar activity at that time. However, the solar activity is really at one of the lows now, apparently. So this plot only goes to about 1997. Over the next 13 years, we've continued to have significant droughts, off and on, but more erratic. We hardly have any average years lately. They tended to be cold and wet, or hot and dry. We do expect that we're going to have continued erratic weather. So we will have droughts, and we will have floods, probably. So that's something that has been occurring. Actually, the anomaly really is the 1970s. There were hardly any droughts at all. It was a relatively cool and wet period throughout that whole decade. So, okay. So, what have been some of the impacts? We mentioned a few, but I did list that the premium wine industry, which is based on the cold tender varieties like Cabernet and Chardonnay, have really been able to expand greatly. A lot of the expansion has been supported by better research on learning how to grow the vines for better cold tolerance and how to prune them or wait, not prune. But I believe a lot of it's been allowed to occur because of the climate change. Bloom dates are tending to get earlier. I'll show you that, giving somewhat longer growing seasons. And our fruit crops are crops that are able to take advantage of that. Some plants, you plant them and 80, 90 days or whatever, they're done. And then if you have a longer growing season, you really don't take advantage of it. Our crops, being perennials, come out as soon as they can in the spring, and they're not really day length controlled. So in the fall, if you have a nice long fall, they just keep their leaves and they keep functioning. And really the places that have the highest yields are the ones that have the longest growing seasons, because the apples and grapes are able to adapt to the length of the growing season. So that's a real advantage of our particular crops. And also apple trees have been looked at dry matter production and potential yields, and they really are able to take advantage of long growing seasons, such as New Zealand, where they can typically produce almost twice as much fruit per hectare as we can in New York. And it's not warmer, so they're able to do this primarily through the extended growing season. Okay, so now, of course, some of the warmer seasons and the droughts, not only a drought, but a cool drought doesn't have nearly the effect as a hot drought. So when you get warmer years and then you get droughts on top of it, the effect is even stronger. So we've had more years with some drought symptoms occurring, at least in the last 40 to 50 years, and thus the need for irrigation. More growers have been putting irrigation in or wishing they had irrigation. But that can be quite good, though, for red wine varieties. Cabernet family don't do very well when it's really moist and humid during the whole season. So the drought years are the years that we get really nice red Cabernet type wines. And Justin China here can talk to you all about some of the reasons for that. So there's a mixture of things that are happening because of that. Now let's look at some examples. Here's the date of apple bloom. These are from about 1965 or so up until the present, and you can see, as with any biological responses, quite variable because they're responding to the climate. But overall, there's been a very significant trend. The rate of change has been about 8 days over that 40-year period or so. So it's a quite marked increase, or earlier bloom of apples. And of course, we're expecting that to continue. This is a plot from Fredonia, where the conquered bloom dates were collected from one experiment that Nelson Shaw set up, while Poole continued and Terry Bates have continued. So these are actually data from the same exact plants for 50 years. Again, you can see the trend is quite clear, not quite as much, 5.5 days or so over that time period. And I think that's because grapes bloom about a month later than apples, and it's more into the summer, which hasn't been warming quite as much. But again, still a fairly clear trend for climate-based responses. Now, I mentioned the CO2. That is not only adds to the climate, the heating issue, but it's also used by plants. And so we have done some studies with our whole canopy balloon chambers here, where we can CO2 enrich them, and we've done some CO2 response curves. Now these are short-term responses, so a lot of different plants will show a similar type of response. Many plants, when they're grown at higher CO2 levels, downregulate because they're really not able to utilize that extra carbon, and so then they tend to downregulate the photosynthesis so that they don't really see a dramatic effect over the long run. We have not really been able to do the free air CO2 enrichment studies that need to be done with our fruit crops. But in general, plants that have a lot of sinks that can adapt, and if you can add sinks to take advantage of the extra carbon, those plants tend to respond much better to long-term carbon dioxide enrichment. And that's one thing about, especially with apples, the number of apples are set early in the season. And during that time of the season, when they're really being set and the final crop numbers are being established, that's the time when the plant is under carbon deficit. So we've done some shorter-term studies with CO2 enrichment or even injection of sorbitol into the trees, and been able to cause a very dramatic increase in the set of those trees. So we're expecting that apples will respond quite well to the extra carbon, because the carbon is limiting at the time they set the sinks, and there's lots and lots of extra sinks. Usually a commercial crop may only be 5 to 10% of the flowers. So we've got a lot of extra sink capacity that we can add. So we think that increased yields due to that increased CO2 may be a very significant factor. And the increase, just as I mentioned, from 320 to 380 is enough to really increase the photosynthesis of the tree. And from our models would suggest that there should have been some increase in fruit set and yields just over the last 30 or 40 years due to that. But of course, we don't have a real experiment to prove it. But, so we think these crops, again, are ones that are likely to respond to the climate, and in some ways, in some positive ways too. So what about the future? What's going to happen? I don't want to go through all of the climate change information. Dave Wolf covered a lot of that. I think maybe Art is going to talk also. But for those that didn't hear Dave, just a few slides to sort of set the stage. There have been several studies on the reported Northeast climate impact assessments, and they're available online at climatechoices.org. So they've done a lot of work, and Dave's been a key contributor to that. And so it's climatechoices.org. Also, if you're interested in grapes, there was a nice article in the Practical Winery magazine by Cahill and Fields that gives a good review and summary of that. So basically, the climate models have different scenarios, and I don't want to go into all those, but basically a lot of the comparisons that I'll show here were done with the lower emission scenario, and that's basically saying that we actually wake up as a society and we stop cranking all this extra CO2 into the air, and we level it out and maybe eventually bring it down maybe by the end of the century. So that's we really behave well. And then the higher one in red is if sort of business as usual, keep going. So on this, there's been we mentioned about 2 degrees warming since 1970, just up till today, the last 40 years. Even with a good lower emissions scenario, because of the inertia of something like this, massive as our oceans and climate, they still expect to see something around a 4 to 6 degree type of increase. So even at least doubling of what we've already seen recently. And then of course the higher scenario, which I think is almost being shown to be not as high as it even should be, is more in the 6, 8, 10, 12 degrees, which of course is a huge change in our climate. But they're using these to sort of bracket what we think would be the best and worst case scenarios. And they use this type of illustration. This is from those publications I mentioned. That are basically saying in yellow, on the left is upstate New York, and on the right is the New York City region. If you look at upstate, from the historical climate in our position there, that by the end of the century, with the best case scenario, we're probably going to be more like Virginia climate in terms of temperature. And then, of course, with the business as usual high emission scenario, we'd be more down into South Carolina, Georgia, Atlanta kind of conditions in 60 to 80 years. And that's within some lifetimes here. So it's sort of a scary scenario. Now, of course, it's very greatly simplified because the climate won't be exactly that way, but this just gives an idea of the type of range when you start talking about those changes and if you look to see climates that have those types of climates, see where you are. So this is also some data from Art about showing in the outline in red is the historic area for snowfall and snow cover during the winter, and then in the white shows again late 60, 80 years from now the type of areas that will have snow cover with their predictions and with the temperature patterns. Now, the exact implications of this, a little bit hard to say. In some cases, snowfall and snow cover is particularly helpful for perennial plants to be able to, especially for some of the wine grapes, to be able to cover the base of the plants. Now, we can't depend on it, but if it does cover the plant, it is a very good insulator. So it may help us survive from those few really cold spells that we do get. But it looks like we're not going to be able to depend on that in the near future. So that's a pretty dramatic change. And again, that's one of those sort of tipping point things. It doesn't take too many degrees of change to go from snow to rain and change the snow cover. There's also been some, I just saw today some data on ice on the Great Lakes. And even though it still varies a lot, in the last, in the 2000s, there's been quite a few years where there's very, very little ice formed. And I can remember on Seneca Lake in the 70s, it actually freezing all the way down to Dresden. And now, probably the grad students here, been here several years, probably have not seen any ice at all. So there have been really dramatic changes in the lakes also. And of course, they're very large bodies to change very much. So, again, mentioned that it'll be warmer, but there'll also be spikes, not only cold spikes, but hot spikes. And so New York City is the hottest place basically in the state, so they're very concerned about that. And so this plot that are provided shows the number of days per year. The main plot over 90 degrees, and again on the left the 1961 to 90, the long term, and then the different lower and higher emission scenarios showing dramatic increases in the numbers of days over 90, and then the inset just shows that they're expecting days over 100 to maybe go from a couple this per year to maybe late in the season with the high emission scenario up to 25, almost a month of over 100-degree temperatures in New York City. That has some really major implications for the city and the state. And I just looked back in this summer, Central Park had 34 days over 90 degrees. I think there were 17 days in July that were over 90 degrees. And that's in Central Park, so it's not like at an airport. Got a lot of pavement either. So, in any case, so we're expecting to see extremes, and also obviously extremes out in the country as well. As I mentioned, the annual precipitation. This is a plot showing the types of variation. This is something that's a lot more difficult to predict because of predicting clouds and rainfall is a lot harder. But they did some averages, and basically they're showing for this region that there's not going to be a dramatic change. There'll be a gradual increase. I think over that time it looks like it's maybe getting up in that 10 to 15% at most type of increase in yields or of rainfall. And again, I think primarily spring and fall as we get into the warmer winters and less snowfall, then it turns into rain. But we're not going to be seeing a lot of reduction in rainfall that some other regions have been seeing. So that's one of the good news. But again, they're predicting, as we have been seeing, greater heavy rainfalls and then maybe dry periods in between. Okay, so let's talk about some of the likely impacts. I've talked about some, and we'll talk a little bit more and project more into the future. Okay, some of the main factors would be the warmer winters. What are the implications of that? More droughts and heavy rain, longer growing seasons, higher CO2 in the air, and likely with warmer winters, more pest and disease pressures and weeds, because we won't be killing them off during the winter as much. So let's look at a few examples and see what we might be expecting. Many of them are extensions of what we have seen, but again, it might be 2- or 3-fold the effect that we've been looking at. With the warmer winters, obviously, we may be able to grow warmer, more tender varieties, especially in the wine grape area. New York is becoming a very well-known wine-producing area now, and with the expansion, there's a great future for the industry, and being able to have a wider range of grapes that can be grown here will be very positive for the industry. However, in the shorter term, we may eventually get to the point where we never have any real winter kill, like in many places, but in the shorter term, we may have this sort of up and down situation. We'll have a warmer winter, but because we may have warmer periods during the winter, the vines may deacclimate some. And so even if it's warmer, we may still get winter injury, not because of the temperature so much as because of the fact that we've had deacclimating periods. And we've already seen this. This is just some plots from Martin Goffinet about the bud acclimation for Cabernet, Riesling, and Concord over a couple different years, just showing the general pattern. And as you can see in the top part here, the same general pattern of the grapes. These would be the temperature. I'm pretty sure these are LT50, or the temperatures at which 50% of the buds will kill. And you can see on the top graph that as you go down through the season, there's some differences in the varieties. But if you notice, say, compare Concord and Cabernet, Cabernet on top is quite a bit slower to get to its maximum hardiness. If you follow down out by January and February, they're really not as different as you might expect. But during the early part of the season, Cabernet is more tender. But yeah, it's a little bit hard to follow the lines, but if you follow them, when they come out of the winter and the spring, the Concord comes out more quickly, and the Cabernet is a little bit slower. So it shows that there's some different patterns of acclimation and deacclimation that could be quite important, and we need to understand those because if we have certain weather patterns, and we can have varieties that better suit or are less responsive to those warm periods, that may be quite helpful. Now the bottom plot just shows the temperatures were going along, and then they really dropped dramatically, and they hit a point where the Cabernets were killed, but they hadn't really equilibrated yet, and so the other Concords and Rieslings were able to survive. Now we saw that this example in a couple different years. One that I mentioned was 2004. 2004 was the January part of this plot, and so in the dark blue, you can see these are the daily minimum temperatures, and so they were bouncing along in November, December or so. And in 1994, which was a year that we got almost, we were within a degree or two of the same cold temperature at the very end, down at the bottom. But you could see that in the period before the coldest temperature, the minimum temperatures really never got above freezing. They're always fairly consistently cold, and so the vines didn't deacclimate. So when they did have the minus 13 or 14, there was bud kill, but it wasn't a major catastrophe for the industry. But in 2004, the blue line, you can see that the period just before the coldest temperature, these are the minimums, and a lot of those days didn't even get to freezing. So we had an abnormally warm period for a significant amount of time, almost 3 weeks. And then it took about 4 or 5 days, and it just went through the floor and hit minus 15, minus 16, depending where you were. And there was massive vine kill and tremendous impact on the industry. So again, the minimum temperatures at the very bottom weren't dramatically different, but it was the warming of that period, of the period before the cold, that really got to us in 2004. So we're expecting that until the climate warms up quite a bit more, that there may be some of these years in between where we might actually see killing at even a higher temperature than we normally see, just because of these deacclimating periods. So that's a concern for the industry. There's not really a lot you can do about it. We basically tend to wait until as late as possible into March and April to do the pruning, so that you can remove canes and cut the buds to look and see what percentage of them are still alive, and then you can adjust the pruning. But we typically we do that pretty much as a normal procedure now. So that's something that we think is likely to happen before we get completely out of the winter kill type of climate. Now, of course, if you have milder winters, then some of the pests and diseases that are killed back by our winters in grapes, Pierce's disease, for example, and there's a lot of other diseases and pests that are to the south of us, and they don't normally make it through our winters here, are likely to make it. It will tend to increase our pesticide loads, probably, because we're going to have to deal with those additional bugs. The ones that we have now probably are not going to go away because the winter is somewhat warmer. They may actually maybe survive even better. So that's a real concern about the warmer climate is the increased pesticide, herbicide load. This is just an example showing kudzu, which we always think of as a real southern type of plant, but excuse me, with these plants are basically the main point. Can't go through all the details, but it's they relate to the number of days below -20 Celsius that is really sort of completely kills kudzu. And basically the point is that kudzu is going to be able to move north if our climate continues to warm this way. So instead of grapevines growing all over our trees, they might be fighting with the kudzu in the future. So that is a real concern now. Now, some of the timing of the seasons. We mentioned that the grapes and things, or the apples, are blooming earlier. In general, and this is not only just for our crops, but for other plants in the spring, generally will be arriving 1 to 2 weeks earlier if it's a lower emission scenario, and maybe up to 3 weeks earlier by, again, 60, 80 years from now. That may be quite positive for us if we need a longer growing season. The growing season is expected to extend longer because of that. One of the issues, though, is if we start getting earlier bud break, are we going to have more frost injury because of that earlier bud break? I'll show you some data there. And then, of course, we expect to have more summer if we're getting longer on both ends. Okay, this issue of spring frost, we went back and looked over that same period of time that I showed you the apple data for Geneva, and we looked for the last 28 degree Fahrenheit -2 Celsius temperatures in the spring, because plant tissues don't freeze at 0. They take a couple of degrees below 0 to freeze the supercooling of the solutes. So we did plot the line above is that same regression I showed you from the apple bloom, and then the regression down below is for the last 28 degree frost. And you can see that those frosts are the last frost is getting earlier and earlier in the year as well. And actually the rate of change is somewhat faster than the rate of change in the apple bloom. 11 days over the 40 years versus 8 or 8.5 days, I think it was. So it doesn't necessarily look like we're going to be expecting more frost than average. I think one of the difficult ones to predict is many times the frosts occur because of clear skies and radiation frost. But trying to predict radiation and cloudiness is something that's really, really difficult. And so that one has a huge error bar, and their climatologists are saying, well, don't try to get anything too specific on that part. But in general, it doesn't look like frosts are staying the same and our crops are getting earlier. They seem to be going along pretty much the same. Okay, so then if we have warmer summers, here's a study saying, okay, for growing premium wine grapes, and these would be in the relatively cool to mild to moderate warmth growing season, which is a fairly simplified way of looking at it. But there was a study done where they looked to see what were the likely changes in climates that are suitable for that type of growing season. And basically, I'm going into a lot of detail. As you move to the right, you can see that, say on the upper left, the areas that are suitable, they show a lot in California, Oregon, Washington. and even in Arizona, in that area, Central Valley of California. It does have a lot of grapes, but they're just saying it's not optimum for premium quality, Cabernet and Chardonnay type of conditions. So, but in the future, they're expecting California to really have very restricted areas that will be more of the Napa Valley or Mendocino or Sonoma type of conditions. But in the upper right-hand corner, you can see that they're really expecting the Northeast to be one area that is benefited by the growing season. Now, again, it's a very simplified approach, which I don't want to read too much into it, but it does suggest that we may be able to benefit where other places are going to be excessively hot. So, now, besides just looking at the general trends and doing some qualitative estimates of what might be going on, we did try to use our carbon balance models that we've been developing, one for grape and apple, and this is a simulation that we did with our VitaSim grape model, where we looked at, this is the simulated daily CO2 fixation or daily respiration per vine, and with the heavy, the black line, the black lines you can see is the top lines are the photosynthesis and the lower ones are the respiration. And the black line is taking an average of a current year that was a quite average year. And I put together, we pulled some months out from different years that had an average mean temperature, but we wanted to keep that variation, not just using a flat mean. So that is sort of our current situation, and then we added 5 degrees Celsius to see what would happen with a 5-degree warming of the average, but we kept that same variation. So you can see several things. One is obviously as we got warmer, we didn't necessarily see any higher maximum photosynthesis of the plants because we're in our summers pretty close to optimum as it is. Where you did see a difference is that because we had a warmer growing season, the trees get started earlier, and so you end up with a longer growing season. So the red line is shifted off to the right at a later part of the growing season, and so you can pick up extra dry matter production there. But of course, the warmer conditions lead to more respiration, and as you can see on the red lines, there are more days that have really suboptimal photosynthesis. And these would be the heat spikes that we'd be expecting to see. So we're using the simulation models to try to look at some of these. And so this is just sort of a summary then on the top, showing that between those two seasons, we suggested that it added up to about a 20% increase in the total photosynthesis, about a 35% increase in the respiration, and because of the respiration lower, so when you take the difference, we got about 10 to 12% or so increase in accumulated dry matter by having that extra 5 degrees. So it's some positive effect, but it's not a dramatic effect. So a summary then would be that with that warmer year, we'll reach those temperatures for bud break about 2 weeks earlier than normal, and end up with a 4 to 5 week longer season. There will be some more photosynthesis, but because of the increased respiration, the net effect isn't as great. The real concerns, though, are possibly not averages, but those spikes, those heat spikes that may be very detrimental to fruit quality. And they're seeing a lot of this a lot more in places like Australia, where they're getting heat spikes, and it's really causing some problems with quality, not necessarily yield. So overall, there's probably a net positive. There may be some episodes that may be maybe a concern. Okay, so what about the situation with more heavy rains and maybe droughts in between? Okay, that suggests that we probably need sites that will have both excellent drainage and good water supply. Well, if you go to a really well-drained site, a lot of times you're short of water, and if you have a site that holds a lot of water, if you get a lot of heavy rains, you may be in trouble. So we definitely will need very good erosion control. So we'll probably have to use cover crops to be able to stabilize the soil, and those will tend to use water also in between times. So maybe the best sites, especially for grapes, will be sites that will be very highly drained, but be sure to have irrigation, a drip irrigation system with it. And in many ways, that actually is a simulation of some of the very best vineyards in the world that produce the best quality. Extremely well drained, but then they actually naturally have deep roots. They have a supply of water, and so maybe we have to artificially use that approach. Okay, some of the other things though is that with more erratic precipitation, you also get more erratic rainfall. Because if you have droughts, typically you've got more sunny conditions because the air is dry, and when it's wet, you've got to have clouds to produce that precipitation. So many crops don't particularly respond that much to, say, a 3 or 4 day period that might have a heavy rain. Well, grapes and apples really can respond quite strongly to short periods, episodes, and those sorts of things. So here's an example of just like a heat spike, where we can look back in our own current data, and this is was just showing in Geneva the temperatures, and this is right in that critical period for apple set, and right at the end of May, early June, and we had, it's a little bit difficult to see, but there were actually about 5 days, above 80 or so, and very warm nights in the mid-60s or so. Just that type of 4 or 5 day heat spike can cause significant reduction in fruit set, especially if the grower is applying a chemical thinner right at that time. You can have some dramatic loss of fruit. I was in Uruguay recently, and about a year ago, they had a very heavy set of apples, and just before they were going to thin, they had 4 cloudy days. It didn't rain all that much, but it was just 4 really cloudy days, and they had a massive drop of fruit. Just a tremendous drop, and it caused not only problems for the growers of not having the crop they needed, but also that all that thinning was done by hand. And so it threw a tremendous number of people out of work. So there were a lot of sociological issues that came up because of that 1 4 day cloudy period. And the growers didn't even notice. It's not something you think about normally. So that's something that is, when you get more erratic weather, more episodes, this could be a real issue for us. And yet the climate modelers say we can't predict that type of thing. It's just too difficult. So, okay, CO2 in the air. It's used for photosynthesis, so there should be increased possibility for dry matter yield, especially in our crops that can take advantage of that. May help with water use efficiency. A lot of times the stomates close somewhat due to the CO2. Even though you're getting more photosynthesis, you may be getting less or not much more increase in water loss. So water use efficiency may be improved. And the effects on apple and quality and wine quality is really not very clear. There was one study with grapes, and they found more yield of a similar quality. So they didn't really see too much effect, but they didn't really get into the flavor profiles either. So that's a big question mark for the grape side. And there has been work done. Luziska has done a lot of work where he had CO2 enrichment plots, and he found that weeds seem to respond much better to CO2 than crops in many cases. So they found that the weed pressure dramatically increased with high CO2, and again, this may lead to higher herbicide loads and concerns that way. So, what are some of the things that we can try to do to adapt to it? Adapting to this unavoidable change is going to require a lot of flexibility. Some of the key issues are we need to understand how soil variability may interact with the climate variability. I mentioned about the water droughts and heavy rainfall. We need to understand what the CO2 is likely to mean, and really needs long-term CO2 enrichment studies, which are very expensive and have become, once they were done with the primary grain crops, then it became not fashionable anymore. So it's been, there is one free air CO2 enrichment project going on in Geisenheim, Germany, which is starting now. They'll have grapes and some apples, I believe, in there also. So it'll be good to see that. And then we need to think more about and study a little more about the winter hardiness responses of these different wine cultivars. And maybe even if we could grow some of them, they may have a response that's not exactly what we need. Okay, some of the adaptation, we can shift to better adapted varieties. Of course, that's that's a fairly obvious one. The breeders ultimately tell us, well, we can solve everything, so we'll breed better varieties. But especially in the wine grape area, people want Cabernet. They don't want Geneva Selection 43 as such. So it's a lot harder when you have named known varieties to change that genotype blend. Other plants that people don't care about the variety can change much more quickly. So we need to be looking also at maybe sites that are going to limit or reduce the effects of the bad components. And then we may need to try to adapt crop management, since we're not changing genotypes, but we do a lot of crop management with these crops. So here, I think probably most of you were here for Greg Jones's talk, and he gave this plot showing the average growing season temperatures and where the different varieties seem to fit. The dashed line on the left is where Geneva is currently, Finger Lakes pretty much. And you can see that it goes pretty much right through Riesling, Pinot Noir, and Chardonnay is pretty good, and we're a little bit cool for Sauvignon Blanc, Semillon, and Cab Franc is right at the edge. And then as you go down, they're really not very feasible to grow some of these other varieties. Now, I put the second line to the right, 2-degree change, and you can see that that's a pretty significant change in the potential varieties. And a 4-degree change is going to push even further. So the level of change that we're talking about is enough to really make us want to be looking in the future. That's not something we have to do right away, which is good because we have little time. But it will be, we will have an opportunity to grow some of the things that we can't now. However, we may be out of the region that's optimum for the things that we do well, like Riesling, signature varieties. Burgundy is almost getting too warm for its own signature variety of Pinot Noir. So that's a concern for the future. The other thing is that any one location, if you have topography, you can, not all sides of a hill have the same environment. So this is in Germany, where they've planted a very, very steep south-facing vineyard to change the sun angle so that it would be more equivalent to, like in, say, Burgundy, France. And so this is one approach. They've actually been finding that it's been getting too warm, and so it's almost not optimum anymore. So one of the things that we may do is, here we're on the cool side, we're pushing things onto better exposures. Maybe in the future, from that red line, we might be wanting to go from the south side with these varieties, and maybe on Riesling, bring it around to the north side. And this ski so we may be able to actually just go around the hill and try to get away from some of the warming that way. So that may be one adaptation. So, and then of course cultural practices. We do a lot of different things. Maybe changing the floor management, as mentioned, the rainfall, but also drought. Putting in irrigation. In grapes we do a lot of work. Now, if it's cool, we're trying to remove leaves to get the fruit into the sun to warm it up. In warm places, they're happy to leave the leaves over top of the fruit to shade them. So we are manipulating the climate within the plant, and so that gives us some possibility of again, manipulating it in a way to counteract the detrimental effects. So, okay, I'm sure gone a little bit long here, but just some closing thoughts on future and what research and things. One is that we certainly need to get a better understanding of crop responses to the environment. There has been a lot of work over the years, but in many cases it hasn't been the interactions between the components of the environment that we're seeing changing. And of course, whenever you're trying to look into the future, you can't do that with experiments very well. So we have to use models more to understand how the plants work and then how they're likely to respond to those changes. And so I think models that have gotten a bad reputation over the years, I think we're going to have to use them more and also understand what their limitations are. But there's, if you look to the future, there's not a lot of choices without using models. And then also there's a lot more outside influences. There'll be carbon credits and things like that may be positive or negative depending on the carbon footprint. But we need to understand how those things will impact our growers as well as just the plants and the environment. And then I think there's a lot of new technologies out and new ways of looking at things that the growers are having to be a lot more aware of. And issues of the consumer. The consumer is looking for things. There's a lot more things about carbon reduction labeling and those sorts of things. So these will have big impacts. So, so I'd like to thank you for your attention. And it's a bit late, but I'd be happy to answer any questions if you have them. Question is, do we have a table for apple varieties similar to that? Well, I haven't actually put it together. I guess, sort of in our head, we sort of know, certainly Macintosh is a very cool seasoned apple variety. It doesn't do well even in the lower Hudson Valley so much, and certainly not down south of us. So, yeah, we sort of have the concept, but I haven't seen anyone actually put that into a table. Okay. Other questions? Ithaca?
Alan?
Right. Yes.
When Greg Jones was here, he talked about, in grapes at least, the bud break was earlier, but there was also a compression of the stages so that a more rapid development moving through the different phenological stages. And if I understood him right, it wasn't actually extending the season for ripening in the grapes because the maturation went more quickly at the high temperatures. Do you see anything like that in apples where instead of getting the longer season that you predict is possible because of frost-free days, just more rapid maturation brings, the apple crop needs to be harvested earlier?
Yeah, actually, it's the stages of development tend to be all pushed somewhat forward. Now, I think there's several aspects of it. One is that if you're in the spring, so bud break to bloom, something like that, that tends to be driven by degree days because they're in a fairly cool time of the season. So that will tend to be compressed if you have a warmer period, except by moving earlier in the season, you're always starting about the same temperature. because that's when the tree senses it's the right temperature to begin to grow. So unless you start earlier and have a more rapid warm-up, if the warm-up rate is the same, then you wouldn't expect to see that period shorten very much. And so I haven't seen a lot of evidence saying that the period from, say, bud break to bloom is going to get dramatically shorter. That tends to be more of a maritime, will be a longer period because it's a slower warm-up, and a continental climate will tend to be a more rapid one because it heats up very quickly. But for us, I don't necessarily expect to see the difference in that period to be that much different. Just everything is shifted forward. The period from with apple, there tends to be a model that was developed by IMP here at Cornell, found that the temperatures after bloom during the cell division period tend to set the number of days to harvest. And so the middle of the season, the degree days don't control growth very well because a lot of times you're right at sort of a maximum of response, and so a few degree days one way or another doesn't affect things too much. So I think generally we expect to see bud break earlier, bloom earlier, not dramatically different, harvest somewhat earlier, but so I think from bud break to harvest I don't really think we're seeing very much change in that period, except everything is shifted forward in the case of apples. But one of the limitations of our climate for our fruit crops is the post-harvest period. Because some years we've actually harvested fruit with snow on them, but there's almost no time at all for the vines to recover, for buds or apples to recover, just to develop additional reserves, get additional root growth after harvest. So I think that post-harvest period is where you're going to see the biggest effect of the climate change, and that's the period that allows the vines and the trees to recover from the crop, and it seems to be able to help the crop set more fruit the next year. I guess I'm still not sure whether we're seeing that type of compression with the types of changes that we've seen.
Is there any evidence for heat stress in vines or apples that curtails growth in the middle of the season when you get these days above 90 or etc.?
Yes, we have seen some cases where we have seen actually sort of bleaching of the leaves when we had a very hot spell with our grapes, and the photosynthesis rate was reduced by fairly significant, about 20 or 30%, and that tended to stay. There wasn't a recovery to that. Sometimes, and I know in areas of Central Valley of California, when you get real heat spells, the vine basically shuts down and really doesn't produce very much, and you'll get delayed ripening because of that. So yeah, I think there's a few studies that have been trying to document that a little bit more, but there's been a lot of observations by growers and, over the years that those heat spells not only cause a problem right at that time, but they can cause problems in terms of longer-term problems of hurting the leaf function. So yeah, there can be some clear effects of those heat spells.
This has been a production of Cornell University, on the web at cornell.edu.